the how to do it for me. Uh,
Recording in progress.
Yep. So that's going to be the almost the final session, because the next session is going to be the same thing, but we're going to have more details about using the CAD CAM. Now, the part you can see in the front of us is a CAD model, has been done by using the Solidwork. And for people in your age, I think it's going to be very hard to know what it is unless if you have a motorcycle. So, guys, do you know what is that? What does it look like? Anyone here have an idea about what's that?
Seems like something in the piston, similar to what we've done in the manufacturing one.
Yeah, you're almost right. Okay, now there's not going to be a piston. Actually, here we're going to call it a barrel. This is a body for something called the carburetor. It was used back in the old cars before they start to use the fuel injection. I think the motorcycle is still using the carburetors. Well, actually, I think that most of the cars now are fuel injection, very rare to have the carburetor, because mainly the carburetor is going to have less efficiency in the burning of the fuel, and thus we're going to have more emission when we're going to use it. But however, at that time, I needed a carburetor for an old car, so I had to do something similar to that. I made the CAD model and I wrote the code for it. The actual carburetor is made from casting of the aluminum, but because I don't have the casting facility, so I decided to machine the part. Especially because in the carburetor, it's not going to have any pressures in it, because the only thing we're going to have is, of course, this is the simple version. We used to have something here to have the flip, and the flip we call the throttle. Every time we're going to open the throttle, we're going to allow more air to come. We're going to have nozzles on the second, because this is the top level. We are going to have lower level here with all the tubes for the fuel to be passed through. Whenever we're going to increase the pressure here, going from here, the outside air going to that side. So we're going to have some negative pressure. It's going to pull more fuel and send it to the duction first, and then we're going to send it to the car cylinders, and thus we're going to make the engine working. Okay, now I made that, and I said, okay, now this can be a good example for my advanced manufacturing students to practice on how to use the CAD CAM on it. In the CAD CAM, instead of do the hand sketch, and then we are going to do the tool path and write down the code, it's much easier to make the CAD model, and then we are going to choose the tools from the CAM software and start to do the machining virtually. And then, of course, the code will be listed. We can simply just copy it, paste on the machine, make some modification, and run it. This can have something about 10,000 lines. That's something that's going to be very long time to be written. And we'll keep this one as second stage. So instead of that, first I'm going to make a very simple part, and I'm going to show you how we can start the process from the beginning. You used the Solidwork before. It's going to be a good opportunity actually to reuse it once again. I don't know why, but can you hear me well, both on Teams and Zoom? Is my voice clear? Because this one's showing very low level here. David, can you hear me?
You're fine on my Teams.
The Teams is perfect. Good.
Yeah, it's good.
Good. Okay. So let's start to do the thing is step by step. Sorry, someone was asking a question. Okay. So once again, just to make refresh your memory with the Solidwork, for the student who finished the university, I don't know if you have an access to Solidwork, but I searched around and I found some of the free CAD/CAM softwares, and but the problem is I couldn't have the time to download them and to practice on them. But the concept is going to be the same. I always think that if I'm going to use the Solidwork or the AutoCAD, It's something like you know how to drive a car. The only difference is going to be driving a car on the right side of the road or on the left side of the road, i.e. that you're driving in Australia or driving in China. So the only thing that's going to be changed is where you sit in the car, but the concept is the same. It's a car after all. So we start with making a new part, and I'm going to schedule a part. I'm going to make a very simple one, and then I'm going to start to add the things one after one. So usually when you, as you remember, that we said that when you take a look to the part, we are going to take a look on it, and we said that the right side is going to be the x-axis, the upper axis is going to be the y-axis, and the depth is going to be the z-axis. So where we can find such coordinates in the Solidwork. Take a look at this thing here. You can see my mouse because usually I have problems that student cannot see my mouse when I share the screen. But anyway, at the X, Y, Z here, we can see that the Z is here, the blue one, the Y is the green, and the X is the red. So the front plane is going to give me this coordination. So I'm going to use the front plane to sketch. This will be the base, and I'm going to build upward. So I will start with the sketch. Again, to do sketch, and I will start with a simple part, having the 0 point here. There's not going to be the 0 point. It's not going to be. This will be for the sketch, but not for the programming. You can see when I'm going to put my pencil on the point, you can at the coordination is going to be 0.26 millimeters and minus 0.52 millimeters. What I'm talking about is this one. So usually when I'm going to put it here, I usually prefer to zoom in. That's just for have a good accuracy and precision when you make the work. Until you're going to have the 0, 0 thing, and then I'm going to sketch my part. I think I'm using the wrong triangle, but however, this is the rectangular shape I have, and I'm going to make the size to be 100 millimeter by 100 millimeter. Usually I like to make such dimension. It's actually look very good. And then I'm going to give it a depth. I will make it as 30 millimeters thickness. Now, when you make the things, you have two options. You're either going to remove the material to have the final shape, or you are going to add the things. These are two techniques we're using when you use a CAD model. What I mean is, I can simply put a cylinder on that face, okay, by either sketch the cylinder, circle shape, then I'm going to make it extrude, okay. This can be one way. Or the other way is, well, I know that the height is going to be different, so I need to increase the height of this one, but I can do it the other way, like go to the features, and I'm going to do the extrude cut, and I'm going to choose that removing this side to the depth of, let's say, 10 millimeters. So we have this cylinder again. So it's either going to be additive or subtraction. So these are two ways to make the geometry at the end. I'm going to remove this one now. I don't need it. Okay, so this will be the first thing we're going to start with. Is going to be a block. Now I'm going to put some details on the block. One of the cuts we can have is having the pocket, or as I mentioned, we can have a part at the top. We will try to make both here. I'm going to add in the pocket first. I'm going to sketch on this surface. And what I'm going to start with is I'm going to make, I need to find the center of that face. So usually I'm going to make an imaginary line. And this line should be for construction because it's not a part of my work. and I can then make my circular shape at the top with a radius of 20 millimeters, and say OK. Now I'm going to do it first as a pocket, and second I'm going to take it up and make it as a cylinder. And when I'm going to do the pocket, it's going to be the pocketing. When I'm going to make a cylinder, it's going to be the profile cutting. So features, I'm going to take this one to the height of 10 millimeters, as you can see here. Okay, and now we have that part, and we are going to work on cut this part. First, I need to save the part. This is very important thing. What I'm going to put here, I'm going to call it as example 1, and save it. Okay. Now, what we have at the Universal Solidwork, I hope I can push this one aside. Yeah, I can take it to the other screen. Okay. So usually the solid cam, which is now added, oh sorry, solid part, we go to the ads in the Solidwork. That's if we're going to use the Celtics Solidwork we have for the UTS. You can see through the ads in. To make the Solidwork running lighter, you remove all the ads in that you don't need, and including the Solidwork cam, this one, which do the same work, but I prefer the Solid cam, which is more advanced and very popular in the industry. So just take that, both. This will make it start at the startup, and this one will start just to add it within the work, and you will see these tabs available for you. Say OK. Now I will start the operation of the solid cam. What I did here was a CAD. I made the computer-aided design part. Just remember that the CAD doesn't mean it's only making the shape, the 3D shape. The CAD means we can make another test on the part, on the shape. For example, I can check what will be the strength of this part by applying the finance element analysis, which is going to tell me where we're going to have the weakness and where we're going to have the strength when we're going to apply stresses on the part. This will be something I need to learn in another subject. The most important thing for us here for the CAD is make the geometry of the part. Now, the CAD is computer-aided manufacturing. And again, the computer-aided manufacturing is not going to be only making the G coding for the part, but also, even if you're going to use the Solidwork, if you're going to use your computer to do the calculation for the payroll, this will be using the computer for the manufacturing process. So it's going to be considered as computer-aided manufacturing process. I just try to explain these things for you. So if you are going to go for any future discussion, it's nice actually. I like it. I always tell David that, because David is one of my old students. I always try to emphasize the people to be a show-off people. Whenever you know something, try to talk about it. Just show the people in front of you that you know about. This will be a good thing. Okay, so wait a second. Do I have any people waiting on the? No, everybody is here. Okay, so now I'm going to start the solid cam operation. So go to the solid cam part, and I'll start with new. Click new. Now this part is going to be milling operation. It's going to be milling turning. It's going to be turning or milling STL. Definitely, this shape is going to be a milling operation. So I will select the first operation, which is going to be the milling. And then the software will start to upload some of the files and start to give me the following. New milling part, create the cam part. Is going to be external or is going to be internal. Usually I like the external, because in the external you can modify the part later. I mean, you're going to make the G coding, and you're going to generate the code and use it. If you're going to make the things internally, you cannot modify that. If you're going to make it externally, you can change your part and remake it once again as a CAD model, CAM model. Where we're going to be saved is going to be saved somewhere here. It's going to be okay. I'm going to have this one as a D, because I'm saving everything on my D thing. We're using the units is going to be the metric. Done. Except that. Why is it? Why it's not working? Something not responding. I don't know. Oh, I think I have a letter here. Oh, directive does not exist. So I'll take it back to the C and say yes. Okay. Now, what we can see is, show me that this will be the Z axis, this will be the X axis, and this will be the Y axis. The machine we're using, we have a list of the machine. Every machine is working according to a certain system. If I'm going to make the drop list here, the most common one we have is going to be the Fanuc, this one. So I can use the Fanuc. The one we have at the university is using the HAT3X. The standard one we have on this software is going to be the Gmailing 3X. And if I would like to make a new one, every company give you the file and you can upload it to this list and you're going to have it there. Anyway, I'm going to use the Fanuc here. Now, we need to define the stock part. So we can click on the stock. And here you can see that I need to select something. The selection is going to be a CAD selection. So I'm going to click on the part itself. It's going to make the green box. This green box identify what will be the shape of the startup piecework I'm going to start with. So of course it's going to be larger than the finished part. And you can see that the added material, you can see from the back it's add some material, a little bit higher from the higher level here. On the sides, we are going to have some extra millimeters. Now, how much this value been added? Take a look on this list. So what's happened is that on the positive x-axis, 2 millimeter has been added. So 2 millimeter from the right side, 2 millimeter from the left side, from the top here, 2 millimeters, from the bottom, 2 millimeters, from the top on the z-axis, we added 2 millimeters, and from the bottom, 6 millimeters. Again, to keep this one as it is. We need actually this extra material, because once again, just to remind you that when you cut a cube like that, you're going to cut it with the saw, and you're going to have very bad surface finishing at the sides, and you need to clean it to have the exact dimensions. So I'm going to leave it as it is. Click yes. Now we need to identify where we're going to have the coordination system. Mainly, this will identify where we're going to have the datum point of the work. Click on that. It's asked me here to select a face. Select face. So I will take a look. We said that the datum point Z value of 0 should be at the top surface of the finished part. So this is the top surface of the finished part. So this level should be Z equal to 0. If I'm going to click on that, okay, done. You can see that at the top surface, lower bottom corner to the left side. This is my datum point. Okay, this will be the Z, the X, the Y. This will be the positive directions, and the other opposite one is going to be negative direction. Okay, say yes. Usually for the rest, we're going to leave it as it is. So I'm not going to change the level for the planar or radial or the rear. I'm going to keep it as it is and say yes. Yes. And the target has been identified by itself, so I'm going to say yes. Now you can see that we do have some pretty, what they call it, it's not boxes. Anyway, we have some operation temples already available here. We can simply just drag it and drop it, and this will do the work. But for me, I'm not going to use them. I'm going to make the processes one by one. Now, what do we need to cut the work? Now, if I get to give you an orange and or apple, I'm going to ask you, okay, now this is the apple. Please divide it to me into 4 equal pieces. What do you need to do that? Oh, come on, guys. That's very basic question. What do you need to cut an apple into an equal pieces? Does someone type something? A knife, which is a knife, which is cutting tool. Okay, so we need a cutting tool. Yeah, cutting tool. So I'm going to use a cutting tool to do that work, and to make the tool, I'm going to go here for the list and search for the tool. It's here. So I'm going to double click on that, and I'm going to have the library of the tools. I can add from the library directly, or I can make my own part. So usually again, to have a flat surface at the top, so again to use the end milling cutting tool. Choose the end mill. The standard dimension we have here is 6 millimeter diameter for the cutting tool. You can see here that everything you read on the diagram can be comparable to the data we have on the side. Now, first we're using the millimeter because that's the standard what we use outside North America. Diameter is 6 millimeter for the D here. The shoulder diameter is 6 millimeter, the ST, okay? That's the ST here. We have the outer diameter is 6 millimeter. That's the diameter. Obviously, this cutting tool will be made of the high-speed steel. For the rest, the total length, we have 80 millimeter. The outside holder length is 60 millimeter, and so on. I can modify that. Of course, when I'm going to modify it, I'm going to modify what the tool is available for me. For example, I can have the tool which have the TL value to be 120 millimeter. This can be used for the debug cuts. And that's what I'm going to use actually for our work later. So tool number 1 is going to have these dimensions, and that's it. I'm going to save and exit because this is the only tool I'm going to need at this stage. I have the tool now. Other thing we can do is, for example, we can decide what the fixture is. Usually for this operation, you need to sketch your fixture. You can make the CAD model for your fixture, and then you can import it to the Solidwork through the fixture thing. Now I will go to the setup directly. I have a cutting tool now. Everything else has been identified. And I get to right-click here and take a look, and I can find that here I have the add of the milling operation. By the way, this is the 2018 version of the SolidCAM. Basically, they are all the same, but the new versions, they just change the name. And I'm going to share a video with you later, show you what are these changing. And also it's going to help you to use the demo version of the SolidCAM, which does not have this operation. So I will go here and try to find the first operation. I need to do some milling operation. So it's going to be 3D milling. Again, it's showing on the other screen, 3D milling here. And I need to define what will be the working area again to work on. Define the working area. So what I need to do for this operation is again to remove a layer from the top by 2 millimeter thickness first, and then I'm going to cut around this cylindrical shape to have the cylindrical shape holding. So I need to select the working area. I need to define the working area. I click here, you can see that we have the pink thing, the pink line. That's mean my work is going to be between the outside purple line and the inside purple circle. For me, I'm going to remove the one inside, which is, I don't know which one it is, but anyway, let's try to delete that. I click on that and ask me, do I need to clean number 2? Yes. So I remove that. Now, why I need to do that? Because I would like to cut 2 millimeter, which been extra added to the work part, to reach the level of the 0 for the top surface. So I click yes. The tool again to use for this operation, need to be defined. So the only tool I have is the 6 millimeter diameter. This will take a long time. But just remember that the work part is 100 by 100. That's mean we need to go something around 16 times passing until again to finish the work. So it's going to be wiser if we're going to make another cutting tool. And this cutting tool is going to have, let's say, 20 millimeter diameter. When I'm going to click that, you will see that when I'm going to go for the next box, everything will be changed automatically. So I'm going to use the 20 millimeter cutting tool to do the cleaning first. So I'm going to save that, and then I'm going to select it as my tool for the facing operation. Now the level I need to go is, the upper level is going to be 2. The lower level is going to be 0. Now what I'm doing is, there's no show up here, but we have 2 millimeter extra at the top need to be removed. The technology I'm going to use for this operation is, we do have rough and we have semi-finishing. For the rough, I'm going to use either the hatch or the cutting tool. The hatch cutting tool is going to go in zigzag shape. And I can use the contour. The contour is going to go in a loop. The overlap is going to be 50%. The step down is going to be by 5 millimeter. We don't have 5, so I'm going to keep it just 2. The wall offset is 0.5. The floor offset is 0.5. I'm going to leave it as it is. Okay, I'm not going to do anything else here, and I think this will be enough. So I'm going to save and exit. Upper level coordinate, yes. Okay, and I had the first operation. So let's see what we are going to have in the first operation. Now, this is the first operation. I'm going to right-click and go for calculate. Calculate is showing me what will be the tool path of the cutting tool to remove the material with the thickness of 2 millimeter from the top and make a new fresh surface for my work. Now, till this point, do you have any question? I did the primarily facing operation for the work part, just to have a fresh surface at the top. I can delete this operation and repeat the steps one by one. Okay, so I'm going to delete that, and we start again, step by step. So I can do the delete, because usually the first operation is going to be the key for going for the next one. Right step, once again, add the milling operation. I will go for the, I can do it for the face, by the way, but 3D milling is going to be the easiest option. First, define the working area you're going to work at. Choose a working area here. Define it. Click on that face, level 1. You're going to have 2 chains. I don't need the inner one. I need to work within the outer purple square. So I'm going to delete the chain number 2. Yes, and I'm going to have that face. Say OK. Say OK. Go for the tool. Select the tool. Tool number 2, because 20 millimeters is going to be faster for the cleaning. The level we're going to work to, the upper level is going to be 2 and positive. That's mean 2 millimeter above the surface. And the lower level is going to be 0, which make it the top surface of the work part. Technology we're going to use here was the pointer. Okay, and the step down is going to be by 2 millimeter, one cut by 2 millimeter thickness, and save and exit and accept that, and then we can do the calculate, which is sketching of the toolpath. So you can see that the toolpath will start from this point, going by squares until it's going to finish. We can actually simulate this operation by going to the simulate, and we will see the simulation in 3 dimension for that part. I have the simulation here. Let's just keep jumping between keep jumping between the screens. Okay, and you can see that the simulation options we have here is either going to be the rest of the material, the machine simulation, which actually a quite advanced thing. I'm not going to do it now because you can see that the part is immersed inside the work part. I don't want to do it now because it's going to cut the table. I will leave it to you to try to take this one a little bit up. We have the 2 dimensions, which is going to do the simulation from the top, as you can see here. I need to make it slower so you can see the cutting tool. Once again. That's too fast. We'll go for the 3 dimension because this will be the best one. Okay, so you can see that the inside to the outside until it's going to clean the whole surface of the face. Now, we finished with the simulation. Now I need to make an operation to cut the cylindrical shape. So once again, we go to the setup. Again, to add a new milling operation, we'll go with the 3D milling. And now what I need to do is define. The definition is going to be the same working area, but I'm not going to remove the inner chain. Now what I need to cut is anything between the purple square and the purple circle. So we're going to actually cleaning that face, the lower one, to that level. Say OK. OK. Now the tool I'm going to use, I can use either, but I will go with the 6 millimeter. So the steps is going to be a little bit longer. The levels. Now the level is going to be quite tricky. Look, if I'm going to put the mouse here, click on that face, this will calculate the value for the upper level. Highlight that and going to the lower face, it will calculate that the depth is going to be minus 10 millimeter. Technology. Technically for that, I'm going to use the pointer because I need to go for a circle around this one. It's going to be much better than using the hatch because zigzag is not going to do the job. I'll go with the pointer. The overlap is 5. We have 10 millimeter depth, so I can go with 5 millimeter each time. But to be more scientifically, I'm going to go with 2.5. So 4 levels that each one is going to be 2 millimeters. The wall offset, I will drop that to 0.1. I only going to leave a little bit material for the finishing operation, and that's it. That's it. So I'm going to save and exit. I'm going to have the second operation. Right click, calculate. Okay, you can see that this will be the dense, how dense the work is. Now, why we have this dense? Because we left 15% offset between the cuts. That means that each time we're going to go down by 3 millimeters only. And this will make it that's why it's going to be 2 dense. And actually, this will be wasting of time in my work. So it's better to go here and make, what is that? The editing. I will edit that and choose another cutting tool. The tool, select, I'm going to choose the 20 millimeter once again, and you will see the difference between both operations, save and exit. You will see that the movement is going to be reduced, the tool path is going to be reduced to 4 only, and that means we're going to save more time in the machining process. More time means less energy, less cost of the machining because the time is going to be reduced. So we're going to simulate this operation, and we're going to make it like in 3D. Spirit. Oh, sorry, that's not 3D. Stop. That's 3D. Yep. Try to make it a little bit faster. So you can see that the cutting tool will remove 2.5 millimeter layer depth each time. Again, down, down, down to again to finish the whole work. Okay. Done. Now, this operation, we did the face milling, we did cut around the part, and now we need to do something else. We need to learn how to make a pocket inside the work part. So just remind you about what the pocket is. For the name is going to be a level, a pocket inside the level. So I can make 2 pockets here. The first one I'm going to make is going to be inside this cylinder. So I'm going to go for the sketch. I'm going to sketch here. And I'm going to make a square shape. Well, I should make it at the center, so this is not going to be perfect. So first I need to find the center rectangular. I will go to the center and sketch my square shape. Now, let's have some good dimension for this one. I usually like to do it like this way. So this will be 20 millimeters. And that is going to be 20 millimeters. And now, before I'm going to do my work, is it possible to cut something like that with the circular cutting tool? The answer definitely is going to be no. Now I need to actually take this one down. So I don't know why these things has been changed a little bit. Sketch. Actually, they changed something here, but I cannot remember what they changed exactly. Sketch. I need to take it down. I'll copy that away. Well, they made it actually more close than to the simulation process than the work we have. Maybe because it's going to the simulation process. Oh, maybe they changed the thing and I cannot actually make the grooves anymore unless we are going to start with the part again. Yep, anyway, because I made it as an external, so I think it's going to be much easier for me to do the work from the beginning. I'm going to upload the same part once again because I don't have the features here. And then I'm going to make the channel at the top. So what was the first one we had? We had the example number 1. Yep. And I'm going to sketch the square here. I know I'm using the old school thing, but it's make me feel more confident. Okay, so once again, if I would like to cut anything with sharp edges on the milling operation, it's not going to work. So we need to change that to have a fillet side. So this will be the square shape, and that will be the pocket we're going to have. I'm going to take it down by 10 millimeters. Say okay. Okay, so to cut such pocket, it's going to be impossible to have the corner on this side. So this needs to be changed into a fillet. Now to do that, I'm going to sketch the fillet, and you can see that from this list, we have the fillet is here. The cutting tool I have is 6 millimeter diameter. That means the fillet I will need to choose is going to be 3 millimeter diameter. So change that to be 3. Of course, going to be millimeters. And I'm going to choose which item need to be a fillet. So I'll just choose the corners here. 1, 2, 3, and 4. So this will be pocket within the cylinder. And also I'm going to make a channel around the cylinder to do the same way. Or maybe I can make a small triangle here and half circle channel as I did last time. So yeah, I'll try to do that. I'm going to make the channel here, and I'm going to make a triangle on that side, and I will try to make a hole on the other side. So let's sketch on that surface, and this will be the thing we're going to learn today. So first I will need to sketch a C shape. The best thing to do that is I'm going to do it like that. Sketch an imaginary line, because I need this line to have the center of the work. Okay, and say okay. I'm going to make an arc, and you're going to use this center. Starting from here, the radius is going to be, let's say it's going to be 35. I'm going to sketch a half circle. I'm going to use this one for construction. And I'm going to use the radius of it to be 35 exactly. Now I'm not having a channel, I have only the arc. But for this arc, I can make the offset of the intensities, make it on bidirectional, and the distance between them is going to be 6 millimeters. Okay, and also I'm going to cap the ends. So this will be the C-shaped channel again to have. Again, to make it with the again to make it with the extrude cut, so it's going to be a pocket with the depth of 5 millimeters. And say okay. So that will be the channel we're going to have as a C-shaped channel. I know it's looked like a clown, so let's finish it as a clown. This will be a nice shape. So now I'm going to sketch 2 triangles, and this will represent the eyes of a clown. I think that the best way to do that is again to sketch a corner. Sorry. Yeah, corner rectangle. Oh, I need to click on this face, sketch, choose that. Okay, so again, to make the triangle starting from here, this will be a quite complicated process, but I always like the challenges. So this one's going to be 10 by 10. So okay, and by 10. I'll make this one 20. Want to find the perfect dimension. So yeah, I'll make this one as the top of the triangle. Okay, so from here, I'm going to sketch a triangle. We'll take it to the depth of 20. Okay, and this side is going to be 15. Okay. Okay, I know that this process is very slow, but don't worry about that. We can solve this problem later. So this side is going to be at 30. Okay. Now I'm going to remove all the parts that I don't want to use later. So I'm going to use the trim intensity and remove everything we made here. This will be an extra part which are not required. This will be my first triangle. I'm going to make another triangle on the other side. So I only going to actually do that. And I'm going to choose, I can do the mirror intensity, but I will use this one. So just send it to the other side and say OK. And I'm going to take both to the depth of 5 millimeters. Okay, and now we have the clown is almost finished. I'm going to change all these edges to be a fillet. So I'm going to choose a fillet. Once again, it's going to be 3 millimeters. Select all your fillet. Now, this is typically not a mechanical engineering work, but at least going to show you how we can do the work of the CAD/CAM. I hope that we don't have people from outside the university see what I'm doing here, because this will be sort of funny way to teach the student on using the CAD/CAM. Okay, and now I need to make the cuts. So obviously, because you can see that this pocket we're going to start with is going to be higher than these pockets. So we're going to start with this one in one of the operation, and then we're going to do the other 3 in the other operation. So we need to save the changes here, and we go once again with the same process of the SolidCAM part. Start with SolidCAM. Okay, sorry. Once again, went to the other screen. I cannot see it. Where is it? Go once again to milling. Okay, and then we're going to start with the, once again, it's going to be external, say okay, and wait for the process to be uploaded. All done. And as we mentioned earlier, we're going to start with the define the machine. I will leave it as it is. Define the stock material. We're going to click on this box. This will be the material we're going to have. Accept that. The coordination system. Identify the highest level of the work, which is going to be this one. Okay, and identify that, and it's all done. The last session I'm going to teach you, I'm going to show you how actually we can make a cut for spherical shape, which is going to be a quite more complicated than what we're doing at the moment. However, this is the part, the datum point has been identified, and we're going to go for the operation. We're going to use the 2 cutting tools, and we're going to finish the work. Part 2, the first one is going to be the end milling with 6 millimeter, say. The other one is going to be the end milling with the 20 millimeter diameter. Enter, and save and exit. We have the 2 tools, and now we're going to go for the operation of the work. The setup, we're going to add a milling operation, and we are going to start with the 3D milling. once again, define the working area you're working at. We said with the first operation, we need to remove the material from the face. We are going to remove the second chain. Say OK. And the rest is going to be quite simple. The tool is going to be the tool number 2, which can remove the material at higher rate. The levels are going to be 2 and 0. The technology we are going to use is going to be the counter. And the step down is going to be by 2 millimeters each time. Save and exit. Yes. Now we said we are going to cut the cylindrical shape. So the second operation is add a milling operation. We can do actually the counter, we can do the pocket, we can do drilling. I will go with 3D milling once again. Define the target. Now this one is going to be much easier because we only need to click on that face. Say OK. Define the tool. Again, it's 20 millimeters to remove the material at higher rate. The levels, now click on the upper level. It's going to be that. Say OK. For the lower level, it's going to be this one, which is -10. Say OK. Technology, again, is going to be the counter. We have 10 millimeters, so we can do it by 2.5 each time to get a good result. The wall offset is going to be 10% only instead of 50%. And we're done with this work. Save and exit. Now the third operation is I'm going to make the pocketing here. I'm going to choose the pocket instead of the 3D milling. So set up, I'm going to add a milling operation of the pocket. Now you can see that the selection has been changed. So it's not going to be exactly the same one. And now what I need to do is define the 3D model protection, define the geometry. I need to define this one. Nope. Okay, so I only need to define what will be the pocket is. So just to click on the lower level here, it will define that this operation is going to be the pocket I will need to make. Choose the tool. I'm going to use the 6 millimeter diameter one because the fillet I have is 3 millimeters. The level, now the upper level is going to be 0. The pocket depth is going to be 10, has been identified automatically. Technology is going to be the counter. I can have the hatch and finish. I can have the black and palm. So I'm going to use the counter. But as a percentage of the tool diameter, we're going to have the minimum overlap, or I can add as 50%. Anyway, I will leave it as percentage of the tool diameter because this will make it an automatic work. I will leave everything as it is, save and exit. And I'm going to repeat the counter for these 3 parts directly. So I can make them in a single shot. Setup, and I'm going to add the milling operation. I will go with the pocket, and I will simply going to choose the geometry here. I can click on that 1, 2, and 3. Now, why we did that? Because they are showing the same height at the top and the same depth. So we can simply combine them all together. The tool we're going to choose is going to be the same one of the 6 millimeter diameter, 3 millimeter radius. The level is going to be the same, -15 from the top. Now, this level is lower than that level by 15 millimeters, and that's why we have the pocket of depth is going to be 15. We can simply divide the steps of the pocketing as an equal steps down. So each time we are going to have the equal depth of the cut, except the last one, because this was 5. So it's going to make it as, for example, 5 divided by 3. Definitely is going to make it as 3, then 10, and then 2. technology we're going to have is going to be the counter and then finishing everything. Now we have all these operations. By the way, you can drag and drop the operation here, okay? But usually this sequence is very important. Just imagine if I'm going to do the pocketing of the lower levels here first. This will wasting the time doing the pocketing, then it's going to remove the layer. So this is not going to be a wise movement. However, you can always do that. You can delete the process and make a new one. It's up to you if you see yourself have a problem. Now we have all the operations not being calculated, so I can, instead of that, going to the setup itself and do the calculate all. So you can see it did the calculation step by step according to the sequence of the operation. Now we can do the simulation with 3D. You will see that through the operation, the cutting tool will be changed. Okay, I have something wrong here because it starts to cut in the air before it starts to cut the pocket. So I will fix that before I'm going to make the final G coding. So I will edit this operation because this will be very important. We're talking about the levels. So the upper level here is not going to be the 0. I'm going to click here and click here. So it's going to start from -10 to the depth of the 5 millimeters. Save and exit. Do the calculation for this operation. Okay, so now it's not going to start to do an extra work in the air before it's going to do the job. Now I'm going to select all the operations already being calculated. And now I would like to generate my G code and send it to the machine. And this will be last thing we're going to learn today. Do the G code all, generate. We're going to call it, like, for example, ADD. Say OK. And it's going to be generated as a file known as NC, which is a numerical control. So you can see that everything has been defined here. So first is going to be the name of the code. The compensation where has been added, the rev, the date of the programming, and then start to choose the definition of the tools we had, and then the whole code has been listed here. So of course, if you would like to do this one by yourself, this will take you something about 2 weeks to finish with it, with too many mistakes. So this will give you the advantage of using the CAD/CAM or the manual G coding. But anyway, that I think that with your ability now, I think you already can write down a manual G code to make this part. If you can do it, raise your hand. Can you write a manual G code to cut this part? It's not harder than the exercise I gave you with the manual G coding. So I'm sure that you can do it. Okay, so I think this will be all for today. I don't want to actually give you a big headache. Next week we're going to, sorry, next session, which is going to be last, we're going to learn how to finish the carburetor part. And also I do have another part which is quite, what is that? It's not here. We have another part with spherical shape, and this will be the part I'm going to show you how to work on it on the next session. Because cutting the spherical shape is on the milling machine is a quite critical operation. It's very easy to cut the spherical shape on the milling machine, but on the milling machine is going to need patience. And that's what we're going to show you in the next session. So thank you for your attendance today. And I hope that once again you learned something new here, hopefully. And we're going to meet you on the next session on Thursday. Once again, it's going to be the last session for this course. At the end, I'm always going to have the open door. If you have any question regarding the G-coding, I'm going to be more than happy to help you with. All good?
Oh, good. Thank you, sir.
Thank you very much. Well, by the way, if you have the access to the Solidwork of Uni, try to do something. Try to play with it. It's a video game. Sketch something and try to apply the CAD/CAM until you're satisfied that you can control the software. Okay, see you later.
Thank you. See you.
Thank you. Bye.